Professor Sumannath. Currently, he is working as an assistant professor and head department of BCA and Computer Science, Srimadi VST Central Institute of Home Science, Bangalore. He has completed his MSc Computer Science with first rank in Dravidian University and also MPhil in Madurai Kamaraj University and did MBA in Punjab Technical University. He also having more than 15 years of teaching experience in different institutes, and he also published a number of research papers in various international and national journals, which is indexed in very reputed research databases. He also delivered guest lectures to different institutes in Karnataka state. He also served a board of studies of chairperson, expert member for Karnataka Public Service Commission, and also played a major role in academic council in the autonomous college. He also a member of various professional bodies, which includes International Association of Engineers, International Computer Science and Engineering Society, and Institute of Engineering Research and Publication. So with your vast experience, now I request Professor Sumannath to enlighten our participants with their knowledge. Thank you. Over to you, sir.
Thank you, sir.
Yeah, screen is coming actually.
Yes, sir. Yes, sir.
1 minute. I think, yeah, it has come.
Yes, sir.
So, yeah, you can maximize. You can
opportunity. Yes, sir. Am I audible, sir?
Can you max? Yeah, you're audible. Can you maximize the screen?
Maximize. I will maximize the screen, sir. Full screen.
Okay. Fine. Yeah, it's fine. Okay, fine.
Okay, sir. Thanks for giving me this opportunity for the this interesting topic, artificial intelligence. Let me touch on various aspects of artificial intelligence. It is a vast subject. In this 1.5 hour duration, I'm going to concentrate on the evolution of AI and what challenges we are facing in AI and what research work is going on in AI, how to carry out the research work in AI field, and the database are available to carry out the research. So the agenda for today's session is like this. Basic concepts and what exactly is AI. And we are going to concentrate on machine learning and deep learning. So we started with AI and we concentrated on machine learning and deep learning because these two are the subsets of AI. Then which are the sectors which are influenced by AI? Something like your healthcare, your agriculture, and so on. So which are the sectors which are influenced by AI? We are going to concentrate on those things. And what are the challenges we are going to face in AI? Research work and the data sets available to carry out the research work. And finally, the application, and we'll conclude the today's session. So this is the agenda for this webinar. Before starting, let us see the revolution of industries, the era of industrial revolution. It is something like this. We are categorized into revolution. First revolution is between 18th to 19th century. So in this industrial revolution, they concentrated on mechanical devices. Some examples are steam engine. So this industrial revolution was not much faster. They migrated to second revolution. They concentrated on electrical revolution, something like a telephone, lights, bulbs, and so on. That is between 1820 to the beginning of the 20th century. That is 1914, somewhere around 1914. So when we compare the second revolution with the second revolution was much faster compared to the first revolution. Then we move to the third revolution, which is somewhere between 1980 to 2010. In this revolution, we concentrate on personal computers, our desktop computers, internet, new communication technologies, So these are much faster compared to the previous two revolutions. These are the industrial revolution. Now in fourth revolution, that is present revolution, we concentrate on the advanced technologies, very important, like artificial intelligence, machine learning, we speak about data, has structured and unstructured data, but it doesn't have enough processing power. Once the processing power is given to those huge amount of data, then we don't find the data. We have IoT of things, we have robotics, nanotechnology, and so on. So this is our fourth industrial revolution, which has much advanced technology, and we need to concentrate on these revolutions to get depth. So we, if we come to the third revolution, if we speak on 3G technology, now we are in 5G technology, right? So we need to concentrate on present revolution. So this is the evolution of AI. Okay, as we know about. So this time is the main current idea of AI started. That is unit, something like a newborn child. Friend, we can say that there was finally during 1950, and it was that during 1970s to some extent recorded as implant. The brain from AI. We use it as a baby, right? A baby which is around 4 to 8 years, right? So it has so in fact there is some improvement in the field, okay? Usually it is recorded as nothing but the one area of AI. That is the funding to the AI sector. The algorithms were developed in this era, is the 1980s, and in 2000 we call it as beta stage. That is what we call it as usually we call it as transitive in. That is nothing but we use the awareness of hardware and we start working on build.
Hello, Suman, sir, Suman sir, Suman sir, sorry for interruption because your voice is breaking in between. Can you adjust your mic properly so that?
Is it okay now, sir?
Yeah, it's now it's okay. Yeah, almost.
Now is it audible, sir?
Yeah, it's audible. Okay, okay, sir.
Okay, sir. And during 2010, it is nothing but the maximum use of something like we have IoT, that's what we have discussed. IoT, virtual reality, augmented reality, big data, artificial intelligence, machine learning, all these things are extensively used, much used in 2010 till present day. This is the evolution of AI. Now, what exactly is AI? This is a branch of processing. It concerns with making your computers behave like humans, right? It can act like a human. It cannot become a human being. Very important. It has this smart thing. It will show, it will behave like a human being, but it cannot become a human being. So it is a branch of computer science concerned with making your computers behave like humans. So AI refers to the ability of the machines, your computers, to perform cognitive tasks like thinking. A human being can think. Now your computers shows that it can think. It can perceive. Your computers can learn. A human being can learn with experience. You're showing, you're proving that your machines can also learn from experience, problem solving, and decision making in field of data analytics. Okay, so artificial intelligence is the ability of the computer program or a machine to think and learn something like a human being does on a phone. So it's also a field of it tries to make the computer smart. So since it is artificial intelligence, that your computers are smart working machines. They work on their own without being independent commands. Very important. So, what we do is the program based on the experience, the mission starts running on its own. We need not code it. So that is artificial intelligence. So what are the very important? Each technology is a research. Computer vision is a technology, audio processing, NLP, natural language processing, knowledge representation, and so on. Each technology is a research field. Export system, your medical analysis. So When I speak about computer vision, it is nothing but a sense. So we have five sense of ours, eyes, and we have so on. Audio processing. All these technologies leads to each field of research. We have illustrative solutions for AI technologies. We have virtual agents, identity analytics, you have biometric, iris recognition, speech analytics, translation of the texture, image, and so on. All these things are the examples of AI. So what constitutes AI? Very important. What constitutes AI? Machine learning. In machine learning, you have supervised, unsupervised, deep learning, and so on. Reinforcement, and so on. All these things put together in machine learning. Machine learning is a subset of AI. Then when you go to NLP, you have classification, extraction, translation, question answering, text generation. Each field is a research. So NLP is also a subfield in AI. You have expert systems, medical field, you have image recognition, you use some image based on the attributes, the output you are going to identify the correct image. Right? Giving supervised labeling for the image. Okay, image recognition is AI. Speech to text conversion from speech to text, text to speech. Speech is also another field of AI. Robotics, 3D painting, all these things. So, what you say, NLP, all this put together contributes towards the field of AI. So, the field of AI has tremendously developed since the introduction of sophisticated techniques and algorithms. Very important. There are various contributors towards this field. You see, like before 1950, Alan Turing, John Newman, Norbert Shalom. And in 1950s, John McCarthy, Alan Newman, Albert Simons. And in 1960s, and 2008, David C. Andrew. All these great personalities contributed to the field of AI. The completed collective resources like Manchester, Berkeley, Stanford University, and so on. So, what constitutes AI? When I speak about this, all the fields like machine learning, your NLP, your expert system, vision, all these things contribute to the field of AI, and each field is a research field. When I speak about machine learning, again you have subfields like deep learning, reinforcement, supervised, unsupervised algorithms, and so on. So same thing could be this slide. So responding, decision making, and case-based reasoning, expert system. When I speak of machine learning, you speak about rectangle system, data mining, that is another field, deep learning, reinforcement, unsupervised, supervised algorithms. Speak about natural processing, you have natural language understanding, mechanical translation, sentiment analysis. So when you speak about computer vision, you speak about recognition, OCR, optical recognition, image recognition, and video recognition, and your face recognition. So each field, you concentrate on each field, each research activity all those contribution, and you can carry out your research. Then what are the breakthroughs in AI? I think this is very important. Breakthrough in AI, spontaneous speech recognition. As we have seen in previous slide, the speech recognition is one of the fields in AI, right? So speech recognition, data set, one should have some data set. It has both inputs and outputs. Okay, when you give a new input, it has to start from the data set. So what are the information new data, whatever you give, it has to extract the result, give the result. Okay, so what are the data set available for this speech recognition? Spoken Wall Street Journal articles and other texts that was in 1999. So between 1994 and 1991, it is almost 3 years. Roughly, it is almost 3 years. And the algorithm for that speech recognition, the first algorithm was hidden mode, and algorithm was proposed in 1984. The difference between the algorithm 1984 and the year of success 1994 is almost 13 years. So if you find the average, it is almost 3 years for the data set and almost 18 years for the algorithm. Let's see the next Gary Kasparov, HSG, right? A mission has defeated a Gary Kasparov. So they have used the data sets in 1991. And the algorithm, the proposed was the Scout planning algorithm, 1983. Okay, success was 1999. So you see once again, 1991 to 1997, the data set and the year of success. So it's almost 6 years. And if you see the algorithm, 1983 to 1999, almost 14 years. So on average, what I can say is the average elapsed time between the key algorithm proposal, the first key algorithm proposal, something like hidden Markov model, and so on. The correspondence advances was about 18 years. 1994 and 1984 for the first speech recognition, 1997 and 1983 second algorithm, network spot algorithm. It was almost 18 years. Whereas the average data time between key data set and the corresponding advances was 3 years. And it is almost 6 times faster. Right? So if you see the data set for the speech recognition, it was available in year 1991 and the success was in 1990. It's almost 3 to 4 years. Okay, so there are many breakthroughs in here. You can see the translation. Google's Arabic to Chinese and from Chinese to English. So all these applications of the can concentrate on these things to carry out your research work. So, we spoke about machine learning. Said that we speak about deep learning. Why we are speaking about these two concepts under AI? Because your machine learning is a subset of artificial intelligence, and your deep learning is also a subset of machine learning, which is in turn a subset of artificial intelligence. So, what exactly is artificial intelligence? The programs with the ability to learn and reason like humans. It cannot become a human being, but it can reason like a human being. So it is a programs with the ability to learn and reason like humans. So what is machine learning? You are going to use the algorithms with the ability to learn without being explicitly programmed. That is the difference between an organic program and machine learning. In organic program, you have the input and program, but when you go to machine learning, you give the input and output. The algorithm will learn based on its experience by using the input and output. But if you input, so what is deep learning? As the name says deep, you have many number of networks. It is somewhat sophisticated, but it gives you almost an accurate result compared to the previous cases. Subset of machine learning in which artificial neural networks adapt and learn from various sources of data. When you see our brain, there are millions of neurons, networks. So each node on the node, the information will be passed. So even our brain has billions of neurons, so it's very fast. So one set of network will work on speech. The other network will work on seeing some object. Okay, so each network will send the information to the next layer in our brain. Something similar to that we are using in the network. So the difference is deep learning uses many number of layers. So it will process the information in each from the past of data. So if you are going to deep learning, if you have huge amount of data, it is better to use deep learning. That's one thing. When you have a limited amount of data, don't go for deep learning. When you have vast amount of data, for training the data, better to use deep learning. The input data and the program say the program that is the program and the focus output. But in case of machine learning, what we do is the machine learning algorithm detects the pattern. It detects pattern and learn how to make predictions and predictions by processing the data and experience. So you are going to detect the patterns. How you are going to detect based on learning, based on the experiences. So based on the experience, you predict, you detect the patterns rather than receiving the program. Programming. We are going to learn based on the experience. So the algorithms also adapt new data. Once you give the new data based on the experience, it will give the result. So if we have huge amount of data and if the training data and the testing data is properly divided, usually we use 70% of training data and 30% of sometimes we use 80% of training data, 20% for testing data. So this is the difference between conventional programming and machine learning. Conventional programming, we use the input data and we program. Say what it should do. And the computer it produces the output. But in case of machine learning, we have the training data and testing data both given. The program itself will trick based on the experience to understand what is training, what is the data used for training, and what is being tested. And once you give a new data, it will predict the patterns. So this is the difference between a conventional programming and machine learning. So breakthrough in machine learning would be Google, then Microsoft. And director here, machine learning is the next internet. So you have machine learning is the hot new thing, right? So we always speak about machine learning. Many research have been performed in machine learning. So, okay, machine learning is today's discontinuity. Jerry and CEO Yahoo. Okay, we have so many codes. So, what is machine learning? The difference between a conventional programming and machine learning. The machine learning is a subset of artificial intelligence. In previous slide, machine learning is a subset of artificial intelligence. Your deep learning is a subset of machine learning, which provides machines the ability to learn automatically. The machines learn automatically. How it learns automatically based on the data, both the training data and testing data, and it improves from experience without being explicitly programmed. So you are not going to write the program. Explicitly program is not done. If you write explicitly program, it becomes a conventional programming. So we have three concepts here. One is descriptive, the second one is predictive, the third one is prescriptive. So what is descriptive? As the name says, you describe what happened, right? You'll be getting some questions in your exam. Describe some concept, right? If you go for Unix, describe Unix file system, right? So what has happened? You write it in detail, right? So that is known as descriptive. What is predictive? You are going to anticipate what will happen. You return your exam, based on your performance, you anticipate you'll be getting a good percentage, right? So based on your input given in your answers, you can anticipate what type of percentage you will get it. So anticipating what will happen based on the previous data. Without taking exam, you cannot anticipate what is your result, right? So employed in data-driven organization as a key source of insight, right? And what is prescriptive? It provides recommendation on what to do to achieve goals. To reach the goal, what you should do, how you need to proceed. That you call as prescriptive. And these are employed in leading data in internet companies. So when we see these three types of analytics, one is descriptive, one is predictive, and prescriptive. If you see the order, your descriptive is what has happened, and your predictive is what will going to happen, and your prescriptive is what to do to reach your goal, to reach your objective, right? So you provide recommendation. So this is the order of analytics. So your descriptive doesn't come under machine learning. Very important. What has happened? Done. So your machine learning provides your predictive and prescriptive. So I'm repeating once again, your machine learning provides, it concentrates on the predictive technology and prescriptive concepts. Okay, so you should know the types of analytics and the order in which you are going to use. So your machine learning always concentrates on the predictive analysis and descriptive. So machine learning this is the you can get it from the technique. The computer program is set to learn from experience C with respect to some class of task T. Right? One job is given, and once a job is given, we have to measure the job. Once you get an assignment and submit, once you write your test, we are going to evaluate your paper and we give the result, right? We give something like 70%, 80%. That is a performance measurement, right? So once the task is there, and we have to measure that performance, that task performance. If the performance of task is very improves with experience, right? I've given you 2 assignments, you have got 80 marks in your main exam. If I give 3 assignments and if you have scored 90%, by giving you more number of assignments, right? That is by experience and learning that if you give more number of assignments, your percentages in your main exam is increased. So, computer says, according to him, the machine learning is a computer program is set to run from experience, So, if I give more number of assignments, you are going to score more marks in your main exam. A computer program is set to run from experience with respect to some class of task P and performance measure. You are measuring the performance P. If the task P is measured by P, improves. If the performance is improved based on the experience, with experience, then you can say your mission has started. Okay, very important. So you based on experience, if you measure the performance, if the performance is increased for that particular task or job, then you can say your mission has started. We have seen the different types of treatments under machine learning. One is supervised, unsupervised, reinforcement learning, and semi-supervised learning. So what is supervised learning? So in exactly an algorithm uses training data from human relationship of human inputs to a given output. So what we do is we give the input, give the output, as well as we are going to label it. So, for example, if we have the principal label, and if you have your HOD room, computer science HOD room, that is another label. The student enters inside the college, and the student wants to meet a principal. Since the room, the student goes inside the principal. The student wants to meet HOD of computer science. Since there is a label HOD instead of the student will move inside the HOD room, right? So you have the input and you have the output and you have the label. If a new data is arrived and the new data based on the training will be classified into respective labels, respective data set. So that is supervised. In case of unsupervised algorithm, there are no labels. Based on the experience, it will be classified. So an algorithm explores input data given an explicit output variable. That is the difference between supervised and unsupervised. In supervised, you give both input and output. And in case of unsupervised, an algorithm explores input data without being given an explicit output variable. So you do not have a label for principal chamber, you do not have a label for HOD of computer science. That is not there. So based on your experience, move to the room and see the chamber, and if the principal is sitting inside the room, if it is a big room, so you can identify that it is a principal chamber. Move to the other room and see if it is a small principal chamber, then you can understand if there are 5 to 6 staff sitting in the HOD room, is the computer science department, something like that. And reinforcement algorithm, an algorithm wants to perform a task simply by trying to maximize rewards it receives for its action. Actions that are moving towards the target. So what is our action? We have to face first semester exam, we have to face second semester exam, and so on. Action and so on. What is reward? Once you pass your first semester, you get your marks card. Once you pass the second semester, you get your another marks card. And once you complete all the 6 semesters, you'll be getting the main degree certificate. That is nothing but you are moved to the objective. To get the certificate. To get your reward, what we have to do? We have to move towards each. We have to move towards each step. Okay, once you perform an action, you get a reward. Once you pass your first semester, you get your marks card. Once you pass your second semester, you get your second semester card. Until you reach your goal, you get until you reach your goal, you have to get rewards. Once you reach your final goal, you get a maximum award. And you should have to perform this. For ourselves, to perform this, to reach your objective, we are going to use the environment as college. College is an environment. who is an agent? Student is an agent. Student get the award. Student get the biggest certificate. So we can call the student as an agent. Environment is college. And what is the reward you are going to get? Reward is nothing but your final degree certificate. So the student has to study and take the exam. Very important. It is the student who has to study and take the exam. So it is the duty of the agent to move towards the objective to get the reward. So student has to face exam and they have to get their marks correct. It is the agent who has to move towards the objective to reach the reward. Very important. So when to use your supervised algorithm? Then you know how to classify the input and type of the behavior you want to predict, but you need the algorithm to calculate it on new data. You have used input data and you have used output data and you have done the training. Everything is done. But you want an algorithm to classify the new data, whether it has to go to principal chamber or whether he has to move to the head of the department. Right? Once a new student enters, you should know how to classify the data to move towards which room. Right? So you are going to use both input and output in supervised learning. But when you are going to use unsupervised, very important. When you do not know how to classify the data, very important. There are no labels. When you know the labels, for example, there are some 5 features are there for some object. And if you know a new object is come, and if that new object has satisfied attributes, then you can put the object in that particular data set. Right? So once you know how to classify the input data, then you can go for supervised learning. When you do not know how to classify the data, there is no label, and you want the algorithm to find the patterns and then classify the data for you, then you go for unsupervised. Very important. When you do not have a lot of training data, when much data is not available, small amount of data, you cannot clearly define the ideal end state, or only way to learn about the environment is to interact with it. So you should know the environment, you should know the you should know all these things, and if you do not have huge amount of data, go for reinforcement algorithm. Right? Usually we use these reinforcement algorithms for optimizing the data in terms of finding the best solution to the given problem, maximizing the total rewards. That is what is semi-supervised? Semi-supervised learning falls between unsupervised and supervised learning. Meaning of that is it has both labeled data and unlabeled data. Both are present in semi-supervised. But in case of semi-supervised, a small amount of labeled data is there. Somewhere around 20 to 30% of labeled data is there, and remaining 70% is your unlabeled data. So your semi-supervised is between supervised and unsupervised. Supervised is labeled data, unsupervised is unlabeled data. So when you concentrate on the percentage sharing of labeled and unlabeled, your semi-supervised consists of small amount of labeled data and unlabeled data. So this is how supervision learning works. So you have the label tags. That is what we have seen, right? You are given the input and you are given the output both. Based on the attributes, your mission starts running. When you give a new data, inside a step 2, you can see when you feed a new data to the mission, the algorithm, what does it do? Based on the training and experience, it will classify whether it is a tag or not a tag. So based on the features, it will identify whether it is tag or not. So labeled, the input itself is labeled, but when you go unsupervised, there is no label. Your mission itself trains, and then based on the features, it itself label it, and then it will classify. So the types of the problem to which you are going to supervise is your classification and your regression. Classification is nothing but dividing based on the features. If you have 3 set of students coming to your college, first sem, 2nd sem, and 5th sem, students are entering inside the college. What you do, you stand in the gate, you send the first sem students to the first sem classroom, so 3rd sem students to the 3rd sem classroom, 5th sem students to the 5th sem classroom. This is nothing but classification. And see the so ID, number of tumors, entity. These are the 4 inputs. And the output, what you are going to do is diagnosis, right? And so in this we have both input as well as output. So what we do is based on the training set, your machine starts learning how to classify the patients, and their diagnosis is not known. So when a new data is given, when input data is often used, obtained, whereas the classification is not. So when a new data is given, something like 101, number of tumors 4, which area 16, average density 95. When you give this, your diagnosis based on the training, based on the previous table, it will identify when the number of tumors are more than 4 and the average density is more than somewhere around 15 to 16 and so on. Based on that, it will classify whether it is malignant or benign. So this is the way to do classification. That's supervised algorithm. And when you speak about unsupervised learning, you are going to give input raw data where there is no errors, no training data set, and unknown output. Based on the machine learning, based on the learning algorithm, it is going to identify, it is going to classify, it is going to label it. So the interpretation is done, and learning algorithm processes this raw data, and based on the processing, it will classify the data into different categories, and then it is going to label it. This is what unsupervised algorithm. So when we speak about semi-supervised, we have said that it is going to fall between supervised and unsupervised, but you have small amount of labeled data and a large amount of unlabeled data. That is what we can see here. Labeled data, a clear-cut classification is there. When you speak about labeled and unlabeled, it's a mixture. Both are there, and supervised learning and semi-supervised learning. Here you have a mixture of both labeled and unlabeled data. So deep learning, that is what you have we have spoken on introduction itself. Deep learning, interconnected layers of software-based characters known as neurons. The number of neurons in each layer of a neural network. The network can ingest vast amount of input data. That's what we see. Whenever you have huge amount of data, vast amount of data, you can go for deep learning. So you can have many number of layers. In each layer, you have many nodes that you call as neurons. So there you can fine-tune the neurons to get the final output. The output is not satisfied, you can fine-tune, change the weights of the neuron, that is node, and you can adjust it, and you can get the output. What amount of input data processed through multiple layers, very important. If you put 2 layers, then you can say it as deep learning. And then through multiple layers, increasingly complex features of data, each layer has many nodes. So likewise, you have many layers. So the network can then make a determination about the data, learn if this determination is correct, and use what it has learned to make a determination of new data. Once again, same thing. You have the data given existing data. You train this data and you have got the output. And a new data is given to this deep learning. It passes to many layers. Each layer have many nodes. It will be processed and it will give you the final output. For example, once it learns what an object looks like, it can recognize the object in a new image. You are training new that image. Once you give a new image, something like a dog image is given, and if you train it to the network based on the existing data set, you compare the cat image attributes. Since it is a dog, it is not a cat. Right? So if you can see here, so we have seen one algorithm, hidden Markov model, right? Something like that. We have hidden layers, number of hidden layers are there. So if you see multiple layers, second one, 2, and 3. So if you have more than 2, you can call it as deep learning. So in each layer has many nodes, we call it as neurons. Right? So there's a each neuron will be each node will be processed, and output. So input is given as a person, and output you can see it as output chart. So once you want to get that output, you have crossed many hidden layers. Each layer has many nodes, so it's very complex. But the machine learns perfectly compared to the previous simple neural network algorithm. So when we are going to use this we have data, and it is not so easy. It is a complex task. It can give you an accurate result. So you see deep learning is simply when training multiple layers. So you have many layers. hidden layers. Input layer, three hidden layers on one output layer. So you can train multiple features are captured from data. Try to the representation DC. So deep learning train layers of the features so that we can classify works well. So what we do, we usually first we take the image, then we do segmentation. After segmentation, we go for classify, right? So we remove not and all things are there. What segment the image, and we can use some classifier to identify the result. For example, cancer is a particular patient is given, the patient is given features that we need to identify whether he is with the cancer and he is the cancer. We do one is the diagnosis. So that's classification is done. That can be classified algorithms. If any given any deep learning algorithm. So if you see deep learning can often outperform your traditional methods. So your deep learning is present technology. The percentage of reduction in error rate achieved by deep learning versus traditional methods. So image classification 40%, 41%, and if you go for facial recognition, the reduction in error rate is almost 27%, and in case of voice recognition, it is 25%. So very important is artificial intelligence sector. Which sector are influenced. So if you see in this slide, it is not a single sector, many sectors are being influenced. So something like healthcare, travel and tourism, your education sector, you will speak about LMS, you will speak about online education, everything, right? Your education sector, your financial services, your transportation and logistics, your media and entertainment, energy and resources, your construction, consumer packaged goods. So your artificial intelligence is applied to wide range of sectors. But Indian government, in India, we are going to concentrate on five main sectors we see in our next slide. Okay, so artificial intelligence has the potential to provide large incremental value to all these sectors, a wide range of sectors. We have seen some sectors here. So the major areas are smart mobility and transportation. You see transportation logistics, your agriculture, your education, your healthcare, your smart cities and infrastructure. These are the major five areas where our Indian government is concentrating. So yeah, some we do not get data. For example, if you want to carry out research in the field of artificial intelligence or machine learning for the brain images, you cannot go to an and ask them. They cannot give you the details. All those details are confidential. So, absence of access to internet data. But if you want to carry out a research, there are some benchmark data set available in the internet. So, high resource cost. So whenever you want to carry out, you should have a fast processing. For that you're going to use, you have to spend more amount of money, and low awareness for adoption of the technology. So we are not being used to the latest technology. So we have to adapt with the new technologies and so on. Privacy and security issues are there. Shortage of skilled manpower. A person who wants to train you in these sectors are not available. And Indian technical is not enough to strengthen the AI ecosystem. Like many IITs, Indian Institute of Science, there are many courses in the field of AI, but not much or not many courses are in these courses and so on. So next thing is these are the challenges in the field of AI. So what are the skills for the AI age? Improve data science coursework and provide certifications to qualified institutes. So they need to introduce a new subjects in the learning data science. But incentive for the creation of AI-related jobs and training the employees with AI skills. Whenever there is a technology, the existing employees, you need to retrain them because they need to cope up with the new technologies and so on. Of course, there is so now it is almost 5 based credit system. So AI is not only with the respect to the field of computer science, your cognitive thinking or civic. Yes, even your psychology field also entered into the field of AI. So you might these courses introduce a psychologist also courses. Conflicts standing in your last one. Okay. Researchers as well as researchers to form universities. There are many research work going on in our many countries like China.
Join again. I think speaker, due to some network connection, speaker left the meeting. We can wait for a few seconds. Let him to join. Sir is trying to rejoin the meeting. Please stay for a second. Sir, it is visible, sir.
So is it visible, sir?
Yeah, visible, visible.
Okay, sir. Thank you, sir. Thank you, sir. And India's AI research ecosystem and intelligence. India has 386 of a total of 22,000 PhDs, educated researchers worldwide, and we are ranked 10th globally in research. India was ranked 13th globally and 44 top-notch presenters at leading AI conferences. So AI researchers are concentrated mostly at institutes like IITs and IISc. That is what we have seen, and many universities have not started much in this AI subject, right? So we need to introduce these subjects in our degree level as well as PG level, but funding is required. And some framework for promoting AI intelligence research, very important. We in India, we have something like ICON, International Centers of New Knowledge, and CROSS, Center for Research on Subsystems. And we have CASTLE, that we call it a Center for Advanced Studies, Translational Research, and Leadership. They focus on development and deployment of application-based research. And we have CETIT, that is Center of Excellence in Technology, Innovation, and Transfer. So we have this four-tier framework for promoting AI research in India. And these 4 tiers are grouped into 2 tiers. That is, ICON and CROSS are grouped into core. That is in next, we can see AI research in India. And the other 2, CASTLE and CETIT, are grouped into ICTAI. So what is this core? They call it a Center of Research Excellence in Artificial Intelligence. Core will focus on core research of AI and will take on the mantle of executing the responsibilities of both ICON, that is International Centers of New Knowledge, as well as it will focus on Center for Research on Subsystems. And we have International Center for Transformational Artificial Intelligence. This ICTAIs will provide the ecosystem for application-based technology development and deployment, and will take on the mantle of executing the responsibilities of both The third one, that is CASTLE, and as well as SETI, that is Center of Excellence in Technology, Innovation and Transfer. So AI in India, opportunities, AI has the potential to drive growth through enabling. You have intelligent automation, ability to automate complex physical world tasks that require adaptability and agility across industries. That is very important. We need to automate everything, but we are not ready to learn. We are not ready to use these systems. That is the problem here. Labor and capital augmentation, that is one other opportunities are there. Innovation diffusion, propelling innovations as it diffuses through the economy. Access to technology easing for the masses, right? And nowadays everything is digital, right? Digitalization, but we need to stick on to that. We need to adapt to that new technology. The demand for AI and machine learning specialists in India could rise about 60%. So every person nowadays uses mobile and digital things, right? Smartphones and everything. So what we need to do is we need to adapt to this new technology. In future, everything is machine learning. So what we do is every day morning we send a message, good morning. The very next day when we type G, it automatically shows GOOD. Why? Because the previous day we would have typed a message, good morning. So your mission starts learning based on our data, right? So we need to stick on to all these things. We need to become a specialist when we start using all this technology. So we have AIRAWAT, IRAWAT, we call it as AI Research, Analytics and Knowledge Assimilation Platform. So this will support advancement of AI-based development in image recognition, very important. Image recognition, we have seen this is one of the technology in AI, the speech recognition, translation. And then you have natural language processing for research, development and creation of varieties of new applications for the support of advancement in the field of agriculture and healthcare. We have many fields, but we concentrated on agriculture, healthcare, education, smart cities, and so on. So as we have seen, some of the institute which concentrated focuses on AI, Center for Artificial Intelligence, IIT Kharagpur, Center for Artificial Intelligence and Robotics, CAIR, DRDO, Robert Bosch Center for Data Science and Artificial Intelligence, IITM, the Artificial Intelligence Group, Department of AI, Artificial Intelligence, IIT Hyderabad, Academia Industry Collaboration on Artificial Intelligence, Laboratory of Statistical Artificial Intelligence and Machine Learning. So these are the premier institutions in India who carry their research work or in the field of AI. So the top 6 collaborations between NIT and NITI Aayog and Tech Giants, the Government of India. The NITI Aayog is nothing but National Institutions for Transforming India. They have collaborations with top giants like Google. They concentrate on AI and machine learning. They start giving training to the engineers who are working in Google and also some courses and so on. And if you go to Microsoft, NITI Aayog and Microsoft India forged a partnership to leverage AI-based solution in 2 sectors. That is one is agriculture and healthcare. So Microsoft, they have into agriculture and healthcare. Redmond Giant will help the Indian think tank in pushing the use of AI, cloud and research and develop vertical expertise in new initiatives and solutions across these 2 fields, that is agriculture, healthcare and environment. When you go for ABB, NITI Aayog and ABB India have signed a statement of intent to support Indian government realize its ambitious vision to make in India through advanced manufacturing technologies that incorporate the latest development in the field of robotics and artificial intelligence. So NITI Aayog will work with ABB to prepare key sectors of the economy, such as the power and water utility sectors. Your Microsoft was with the agriculture and healthcare. Your ABB is with power and water utility sectors. Industries like food, as well as the heavy industry sectors and transport, that is your metro and so on. And Intel, NITI Aayog, Intel and Tata Institute of Fundamental Research announced in September that they are collaborating to set up a model international center for transformative artificial intelligence. Why I'm projecting all these things is there are many opportunities in future in the field of AI. You can see IBM, NITI Aayog and IBM signed a statement of intent in May to develop a crop yield prediction model using AI. Crop yield, your AI, your machine learning will send a message to your mobile phone when to yield a crop. So that this is also once again in the field of agriculture. So it will provide a real-time advisory to farmers in aspirational districts. So based on the environment, based on the data, your AI applications will learn, and it will send the messages to the agriculturists when to yield a crop and so on. Okay, the partnership aims to work together towards the use of technology to provide insights to the farmers to improve, very important, to improve the crop productivity, the soil yield, control agricultural inputs with the overarching goal of improving farmers' incomes. Okay, and SAP, Niti Aayog Atal Information Mission signed a statement of intent with SAP in March 2018 as a part of SOI. SAP in 2018 will adopt 100 Atal Tinkering Laboratories for 5 years to nurture the science, technology, engineering, and mathematics learning among secondary schools across India. They will provide training, hands-on experience to use all these 5 technologies: science, technology, engineering, and mathematics learning. So transitioning jobs, once mission learning on intelligent mission, once the mission becomes intelligent, there will be a job cut for the human beings until if we stick on to the new technology, and if we learn the new technology, we are going to enjoy the fruit of that new technology. Otherwise, it becomes very difficult. For example, AI tells the drilling technician which oil deposits to target, and intelligent drills calculate the speed, pressure, and depth. So we need to understand the technique. We need to understand the AI technology. Then we will be a part with the mission. We have seen in previous slide, human plus mission together, right? It is not just a mission or just a human being. So we need to adapt to the new technology. Then we'll be in the field of AI. Otherwise, it will become very difficult for us to gain jobs in these fields. So NASSCOM predicts that by 2022, a starting 46% of the Indian workforce will be engaged in entirely new jobs. If you want that new jobs, we need to stick on to the new technology that do not exist today, or jobs that have radically changed skill set. So reworking the revolution. So this is the source from the Accenture. So data sets. We spoke about carrying a research. So you want the data. From where do we get data? Some data are confidential, and you cannot get those data from that organizations, right? So how do you carry the research? Very difficult. So how do you get the data set for AI? So when you want to go for the computer vision and image processing, you have the data set from MNIST, where you have 60,000 data set. The size is 60,000. So 60,000 in a sense, we have almost 6,000 images per class. So you have 10 classes. In each class, you have 6,000. So something like a car. Car is one class. You have 6,000 cars. Then you have birds. Birds is another class. You have 6,000 birds. Then you have cats, 6,000 cats. Likewise, you have 10 classes like ships, horses, frogs, dogs, and so on. So you have 60,000 data set. And the publisher of that data set is United States Census Bureau. These are benchmark data sets. You can use these data sets to carry out your research work. And you can publish your result. Okay. And the country is USA. Likewise, you have CIFAR. Sorry, in MNIST you have 60,000. That is different. And in CIFAR you have 60,000. Sorry, 60,000 data sets. Once again, you have 10 classes here. And likewise, you have ImageNet. And this image database is organized to worldwide hierarchy, WorldNet hierarchy, ImageNet. And you have LSUN. That is nothing but large scale scene understanding. You have so many data sets. All these are benchmark data sets. Use these data sets and carry out research work. So MNIST is not for images for like cats and birds and so on. That is for CIFAR, which is nothing but Canadian Institute for Advanced Research, where you have 10 classes. Each class has 6,000 images. And MNIST is for handwritten digits. That is commonly used for training various image processing systems. So MNIST is for handwritten digits. CIFAR is for 10 classes which has images like cars, birds, cats, and so on. And if you want to carry out your NLP research, and if you want the data set, we have TREC, TREC, you have that is text retrieval conferences. Then you have Wikitext, which contains syntaxes, keywords, and so on. And you have question pairs, document returns in a wiki markup languages. In question pairs, you have so many question paper questions, and you have to train them, and you have to test them, and so on. So we have all these data sets available, benchmark data sets, for carrying out our research work. So what are the applications of AI and ML? So you have autonomous vehicle. What is autonomous vehicle? It is independent, without a driver, self-driving cars. And we have medical diagnosis, expert systems. creating art such as poetry and so on, proving some mathematical theorems, search engines, image recognition, prediction of judicial decisions, and targeting online advertisements. And your favorite area, everything falls under the applications of AI. When you speak about machine learning applications, as we have seen in beginning itself, your machine learning is a subset of AI. All your examples of applications of AI is a part of your ML applications also. Your face detection, your object detection, whether it is a car, cat, dog, and so on. Your image segmentation, dividing your images, segmenting your images. You have so many algorithms for segmentation also. You have some tools, statistical parametric mapping. If you want to segment your brain images, you are going to use SPM, SPM5, SPM12, and so on. You have ready-made tools for segmentation and so on. Without, if you doesn't want to use algorithm, if you want some tools for segmentation, you can go for that. Multimedia event detection, web search, finance, e-commerce, robotics, and your favorite area. All these falls under the applications of machine learning. The application of AI is also a part of machine learning. So Google Map, applications of AI. You would have used Google Map to save our time and to choose a short route. And if you want to know where there is a traffic in that area, in that route which you are traveling, use Google Map, right? Google Maps, the app which we use every time we go out. So despite of the usual traffic, you are on the fastest route, right? It will guide you. Everyone who is using the Google Map is contributing. They're making some contribution to the app to make it more accurate. So Facebook, what will we tag our names, right? So Facebook suggests if you want to tag the person in the picture, uses Facebook face detection and recognition algorithm. Once again, AI, right? Sometimes we use a camera and we when we focus our camera to a mobile this thing, to show it to show our age sometimes, right? To show somewhere you are 25, 30, 35, 40, something like that. So based on this thing, data it will show that. So use Facebook face detection and recognition algorithm based on the project that is known as Deep Face. So this is Facebook, and you have machine learning at Uber, right? Personalized application, estimated time of arrival. So it will show the moving, based on the distance. It will show you, it will estimate and give you 6 minutes. The car will be available at your doorstep. Right? Recommends as based on a search history. Right? Amazon. If you start purchasing only electronic items, your computer-based items, it will give you, it will advertise you that these new items are available for purchase. Right? Based on your search history, it will recommend you the items. So machine learning is used in generating recommendations, applications of AI. 35% of the Amazon's revenue is generated by its recommendation system. An iPhone, smartphone with facial recognition, right? Nowadays, you unlock your mobile with your facial recognition. Core of the face detection machine learning algorithm, very important. The face detection based on your machine learning algorithm, and the driverless car that we have seen. The Tesla's AI is driven by NVIDIA's hardware, focusing mainly on unsupervised learning. We have seen supervised and unsupervised learning. Crowdsources data from all of its vehicles and it drives. There was internal and external sensors. So you have a sensor, it will identify the distance, the speed, the car moving in front of your car, and so on. And Netflix, I think you'll be knowing this. Based on your interest of the movies, you can download all these things. It will give you the data based on your interest. 75% of the users selects movie based on Netflix recommendation. And the robot chef can replicate a dish cooked by any master chef in the world, robots. And Google Translator. Language is no more a barrier. If you doesn't know the language, you need not worry. Just take a snapshot, your Google will translate and it will give you the information. Free, fast, and providing almost accurate translation. Real-time translation camera. It is almost accurate, not 100% accurate. And a robot, you can see all these things. A German manufacturer of industrial robot and solutions for factory automation. So the final conclusion is artificial intelligence presents opportunity. You have many opportunities, many researchers, many institutions, and your government is funding on this field. You need to complement and supplement human intelligence and enrich the way people work. So AI for all and AI for everyone. So many opportunities are there. We need to stick on to new technology. We need to learn the latest technology, adapt to new technology. So we'll be in this field. That is what I want to conclude. Biju sir.
Thank you, sir. A very good afternoon to one
Thank
and
you.
all. I am Miss Pranita Katakwar here, Assistant Professor from the Department of Computer Science, St. Francis de Sales College, Nagpur. Thank you, sir, for the wonderful session. Sir, can we go towards the question answer session? Because participants have much more doubts and difficulties. So,
Yes, ma'am.
hello, students. Please unmute your mic. Hello, students, participants. Please unmute your mic and ask your doubts and questions to the sir directly. Hello, students. Hello, participants. You have any doubts? So please ask to the sir directly. Uh, yes, participants, if you have any query, so ask to the sir directly. Please unmute your mic and ask to the sir directly. Okay. Okay, sir, there is no any participants. But if we are going according to the registration form, so we have number of questions, sir. So
Yes,
can I
please tell me.
start my first question? Yes, sir.
Yes, ma'am. Tell me, ma'am.
Yes, sir. Thank you. So my first question is, can you clarify what is the virtual agent?
Virtual. Hello.
Can you clarify what is the virtual agent?
Virtual agent. Okay, madam. I'll give you one example. The thing is, nowadays we do not have an offline class, right? Offline class is not there. We speak about online class. Hello.
Uh,
Am I audible, madam?
yes, sir. Yes, sir.
Right.
You are clear now. Sir, actually there are two participants. Actually, there are two participants who are registered and they have queries. Uh,
Yes, madam. Yes, madam.
I think Anu, can you unmute your mic? Can you ask a question? Anu, can you unmute your mic? Can you ask? Okay, sir. Someone, sir, just go with your
Yes, sir. Yes,
answer.
sir.
Okay.
so my next question is. So my next question is, what are the
Yes, yes.
different applications of AI in natural language processing? What
Natural
are the
language
different
processing.
applications
Yes,
of
madam.
AI in natural language processing?
Speech recognition, translation,
Yes, sir.
text translation. We have seen, madam. Just
Yes,
now we
sir.
have seen it in images also at the last applications of AI in that natural language processing. 1 minute.
Okay. Okay, sir. My next question is, how AI helps to tackle the stress and tension of the human brain?
How
How
AI,
AI helps, yes, how AI helps to tackle the stress and tensions of the human brain.
human brain has number of neurons. Yes, madam. And what we do is we use the brain images. We take the brain images. We analyze it by using the machine learning algorithm. So what we do is we segment the images. Then we select the best features. We train the data, and then we use some classifiers. The best classifier is something like artificial neural network, structured optimized neural network, and we analyze and we classify the data.
Okay, sir. Thank you. And my next question is, Again, is there any virtual simulation tool available to work on AI system research method? Is there any
Virtualization
virtual
tool, right?
simulation tool available
But
to
there are
work
many.
on AI system research method?
Madam, right now, actually, what we are doing is I'm using SPM, Statistical Parametric Mapping tool for brain images. In my research. So, in different sectors, there might be a different simulator.
Yes, sir. And my last question is that how AI can be applied in human resource management to streamline the process and improve efficiency?
Yes, madam. Nowadays, we use LMS, Learning Management System. Earlier, we used to teach the students in offline classes. We used to evaluate student answers and all those things. Nowadays, everything is virtualization, virtual classes, everything. So the students are also trained with this smart technology, and we are also using this smart technology, and we are evaluating the student performance by using this technology, and we are finally getting the result within no time. Likewise, even in industry, they are going to train these employees by using these AI technologies. They are going to use vast amount of data from some organization, and they will see the growth of that organization, and those experience will be implemented in our organization to increase the profit of our organization.
Okay. Thank you, sir. Your talk was very good and full of knowledge. Along with AI, you explained what is machine learning, what is deep learning, how it works, and for what type of problems it is well suited, and their application in details with a good example. You also focus on different research area in AI. This will definitely benefit our student as well as faculty members also. Thank you, sir. It is very informative and interesting session. So now I would like to thanks to Professor Sumanath sir for enlightening us with their knowledge. Today's webinar was full of knowledge and interesting fact. I am sure the knowledge that sir gave us will definitely help us in our future study. So thank you so much, sir, for your valuable time and valuable knowledge. I would also like to thank our principal, Katie Thomas, sir, and college management for giving permission to organizing this webinar session. I would like to thank to our HOD Biju, sir, for inviting Professor Somanath, sir, and conducting webinar on such interesting topic. I want to thank organizing team, technical team, management team, and college staff for their support, for their help and hard work. I want to thank the students who are present here online and paying their attention and learning. So thanks to all of you. Thank you. Now I request all the participants to stand for the national anthem.
हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, madam. Thank you, madam.
There is Suman sir.